Folks, welcome back to another video. Today, we're looking at question 79 of word search. The way we'll be solving this problem is by using BFS. BFS basically means you go in all the positive directions that you can, one step at a time, to see if it holds the next condition. And then if it works, you go into the next condition, which basically here means going through one letter through the next. So let's get started. First, you need to get the dimensions of the entire array that's given to us. So let's do board.length. This will give us a number of rows, and number of columns would be to take the first row and get the length of that. Right. So we need to iterate through all of the cells in the board. So let's do int I equals 0, I less than m, increment I. This iterates through all of the rows. Let's go through the columns for int j equals 0, j less than n, j plus plus. Awesome, just iterates through all of the columns. And next up, we do if word dot character at 0 if the first letter in the word is equal to the current spot that we're looking at in the board, which is I of j, then you need to do binary search, not binary search, breadth first search on that. So you call the binary search on it. Yeah, and then you would say, so basically this search will return a value. If it returns true, we would return true. We end early and we return true. If not, we return false. Awesome. So this is just like the skeleton. Obviously, the meat of the problem is right here. So let's build that out. So this can be a private method. What we're returning is a Boolean value and the name of the function of search. So what are the things that we need? We need the board itself to go through all of it. We need the current index of the letter that we're looking at in the word. So actually, let's do rows first, just because it's close to board. We have to take the rows and the column that we're looking at, and then we need the word itself. What else? And we need the index that we're looking at in the word, and we also need a 2D array of Boolean values, which basically represents whether a particular cell has been visited or not. So this would be Boolean visited. So these are the things that we need. So let's pass that, right? So we need to pass board, we need to pass I, we need to pass j, we need to pass word, we need to pass the index, and in our case, it would be, so you're looking at the, yeah, I think we need to pass the index 0 itself, because we are passing the current row and the current column. So you don't iterate it. So you just pass 0 and visited. We don't have a visited Boolean 2D array yet. So let's create that. Boolean visited new Boolean of m and n. Awesome. And yeah, this is passed right here. Visited. Okay. And just to test this, let's just return false. So basically, when your problem becomes overly complicated, it's better to just test what's going on after you write at least like a significant piece of code, just so you know what's up. So at least it's compiled, so we know we don't have any errors. So let's work on this part, right? So anytime there's some sort of a searching recursive function, you need a base case or like a stopping condition. So in this case, if the index is all the way, if the index has reached all the way at the end, which would mean in our case, word of so the index is equal to the word dot length because our index starts with 0. That means the index has already bypassed uh, bypass the entire word, and it works so far, so you would just return true. Next up, what you need to do is you need to like go in all 4 directions. So if I is less than 0, yeah, or if j is less than 0, or if I is greater than or equal to right, board dot length, or if j is greater than or equal to board of 0 dot length, we could possibly extract them and pass them into the method itself, but it's fine for now. So you're basically checking the new rows and the new columns that are given to us are in within bounds, and then you check if it is visited, and if board of I of j, if it is not equal to the character that we're looking at, word dot character at index, then you would return false. But let's clean this up a little bit. Okay, as long as it makes sense to y'all, or it's like easy to read. Okay, so if I is less than 0 and j is less than 0, if it is greater than the length of the board itself, or if the current index has been visited, or if the letter that we're looking at is not the letter that's on the board, that means all of these conditions would result in basically that cycle returning false. If this hasn't returned false, you can go ahead and check the other condition. So basically, you can send the pointer top, down, left, and right. So if you need to basically send this back, so you're calling this recursively, you need to pass board, and then let's say you first want to increment I, and then you keep j as is. So basically, this is going to the cell on the right to check, and then this will be a word, and then index would be +1, and we actually, before that, we need to mark the current cell as visited, because we already visited it and we have checked that it works. So you mark this as true, and then index would be index +1, and then visited. And this you need to repeat in all 4 directions. So this is right. So let's do it for all of the others. Okay, I wonder if this looks cleaner. I think this is fine. Okay. Okay, cool. All right, so here you incremented I, but here we decrement I, and here we keep I as is, and you increment J, so you're basically moving to the next column, and this right here, you're moving to the previous column. And then if any of this returns true, then you would return true. If not, you want this loop to keep continuing, so you mark the current as false, and in the end you would just return true because it comes all the way to the end and it wouldn't have been returned here. Awesome. Okay, let's try compiling this. Ooh, okay. The first two cases are correct. The last case is false. So output is true, expected false. So let's see here. A, B, C, and E. Oh, right, doesn't support. The word would be A, C, C, B. So it's returning true. It's returning true. Wait, is the base? Oh, no, sorry, here. So this should return true. And I think this should actually return false. Right, yeah. So basically, the only time you want to return true is when you've actually reached the end of the word, and if any of these conditions hold true, because that would have returned true, you return this as true as well. If not, you return false. So the first few test cases are okay. Let's submit this. Everything else is okay as well. Awesome. So let's talk about the space and the time complexity of the entire solution. So the time complexity of the entire solution is n into m, because we iterate through all of the rows and the columns, and 4 to the power of L. L here represents the length of the word, and since we are we're going in all 4 directions right here, and we have to do that L number of times, so it'll be 4 to the power of L. So that's the reason why that's the time complexity. The space complexity is O into O of n into m, because we are using additional space to store whether a particular cell has been visited or not. Awesome. If you have any questions, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I'd really appreciate that. It keeps me motivated to make more videos. Thank